In this question, it is given that for x belonging to set of real numbers, let the function yx be the solution of the differential equation this, and y0 equal to 0 is also given to you. Then which of the following statement is oblique or true? You have to find the correct choice. Before I do this question, I would like to tell you few formulas which will be very helpful and should be always known to you. First is e to power ax sin bx dx. This is equal to e to power ax a sin bx minus b cos bx upon a square plus b square. And similarly, one more formula is e to power ax cos bx dx is equal to e to power ax a cos bx plus b sin bx upon a square plus b square. The main problem in remembering this formula is after a long time, if you try to recall this formula, then confusion arises in which formula minus is there and in which formula plus is there. For example, this. Suppose you have written e to power ax a sin bx plus b cos bx upon a square plus b square. Put a equal to 0 and b equal to 1 in both the formulas and see which one gives the correct answer. If I take a equal to 0, b equal to 1, it will become sin x. The answer should be minus cos x. In this formula, you are getting minus cos x, but in this formula, you will be getting cos x. Hence, immediately I can say this is wrong. In this way, you can always recall the formula of this. And the second concept which I will be using while solving this question is, suppose y equal to e to power x plus say sin x is there. And if I want to draw the graph of this, we know that the graph of y equal to e to power x is this one. Suppose I want to draw the graph of this. It is clear that the values of x for which this is positive, for those values of x, the graph of this will be above the graph of this. And the values of x for which sin x is negative, for those values of x, the graph of this will be below the graph of this. Obviously, the graph of this will become from 0 to pi, the graph of this will be above the graph of this. From pi to 2 pi, the graph of this will be below the graph of this, and so on. And the next point which should be known to you is any function of the type a sin x plus b cos x can always be written in the form of r sin x plus theta, or can also be converted to the form of r cos x plus theta or minus theta. Both are possible. For example, if I want to convert this into this form, take a equal to r cos theta, b equal to r sin theta. Then it is clear that r will be equal to under root a square plus b square, and tan theta will be b by a, that is theta will be tan inverse b by a, and by using this can be written as r sin x cos theta plus cos x sin theta, that is, it will become r sin x plus theta. Actually, all of you must be knowing this thing. I have told you just for you to be able to recall. And now let us come to the question. To solve this differential equation, it is clear that it is a linear differential equation. Therefore, first of all, we will find integrative factor. It will be e to power p dx. P is 12 dx, that is e to power 12x. Therefore, the solution of this will be y into e to power 12x equal to e to power 12x cos pi by 12x dx. And as I told you just now, e to power ax cos bx is e to power ax a cos bx plus b sin bx upon a square plus b square. Using this formula, I get y into e to power 12x is equal to e to power 12x into 12 cos pi by 12x plus pi by 12 sin pi by 12x whole upon 12 square plus pi by 12 whole square plus c. To find the value of c, I'll be taking the help of this information that y0 equals 0. That is, for x equals 0, the value of y is 0. That is, I get 0 equal to 12 upon 12 square plus pi by 12 square plus c. That is, I get c equal to minus 12 upon 12 square plus pi by 12 whole square. Hence, I get y is equal to 12 cos pi by 12 x plus pi by 12 sin pi by 12 x upon 12 square plus pi by 12 square minus 12 upon 12 square plus pi by 12 whole square into e to power minus 12x. It's clear that the value of y is in the form of a sin pi by 12x plus b cos pi by 12x. This upon this is a and this upon this is b. Minus, I name this constant as e to power minus 12x. And as I told you in the very beginning, that I can bring it in the form of r sin pi by 12x plus theta minus alpha e to power minus 12x. And now I will check the choices. In choice A and B, he is asking about the increasing and decreasing. Therefore, first I find dy by dx, this is r pi by 12 cos pi by 12 x plus theta plus 12 alpha e power minus 12 x. It's clear that if I take a very large value of x, say pi by 12 x plus theta, say it is so, if I take the value of x such that this is equal to this, it will be nearly 0, but the value of this will be r pi by 12, that is d over dx is positive for this value. But if I take the value of x such that this becomes plus pi, in that case it will become minus r pi by 12 and it will be still very small. As a whole, it will become negative for this value. Hence, d over dx can be positive also and negative also. Therefore, choice A and B both are wrong. And to check the choice C, first I make you understand the graph of this. As I told you in the very beginning, the graph of y equal to e power minus 12x will be this point is 0, 1. The graph of y equal to alpha e power minus 12x, the graph of this will be, this point is 0 alpha. And now the graph of y equal to minus alpha e power minus 12x will be this one, this point being 0 comma minus alpha. And now after this, if I want to draw the graph of y equal to minus alpha e power minus 12x plus sine pi by 12 x plus theta into r, that is this one. Because the maximum value of this is r and the minimum value of this is minus r, hence the graph of this will be sometimes above the graph of this and sometimes the graph of this will be below the graph of this, depends upon this is positive or negative. If it is positive, the graph of this will be above the graph of this. If it is negative, the graph of this will be below the graph of this. Hence I can say the graph of this will be of the type, this yellow line will be the graph of this whole. Maximum it can go up by r unit because the maximum value of this is r. Minimum it can go below by r unit. That is, the yellow line will be the graph of this. It's clear that this white line graph is going on coming nearer and nearer to x-axis. Hence, if I draw a line very near to x-axis, below or up makes no problem. If I draw a line very near to x-axis, then this line will surely cut the yellow graph at infinite number of points. Hence, C choice is correct. And in D choice, yx is a periodic function is wrong because yx is a sum of periodic and non-periodic function, and sum or difference of periodic and non-periodic is always non-periodic. Hence, D choice is wrong.